Hey guys, there is this wonderful function which I really love and which I very fondly call as Baba function. That's nothing but the modulus function, or as we call it, the absolute value function. It's very important for JEE. It's very important for every topic. So functions, quadratic equations, sequence and progressions, your entire calculus, any chapter you talk about, this function is the base of all the calculations there. So today we are going to master modulus function, a function where, or a concept where students make most number of mistakes. So if you analyze the IIT paper, which I have done with many of my students, something which is asked a lot in JEE exam questions and the concept where students make a lot of mistake, that is modulus function, which I very fondly call as Baba function. It's a cute monk, it's a cute Baba which spreads positivity in this world, and let's learn why. By the way, I am Pulkit, co-founder of Vedantu, and you are learning with me the basics of all the basic concepts which will be used in maths in all the topics ahead. This is my Telegram link where you can join me and you can get access to the assignments and multiple things that I keep sharing. Chalo, let's begin. So, bachon, to begin with, let us first understand what is a function first of all, right? What is this function? So, we usually write function as y as a function of x. Read it with me. Y is equal to function of x, right? Now, so f represents a function, a rule, I'll come to that. But here, you know what? Think of it like a mixie. Do you see a mixie here? Do you like a juicer or kind of a mixie here, right? If you put certain input in it, it will create some sort of a shake or a juice or a smoothie, something, right? So that depends on the property of the juicer. So some input gives you some output. Some input, bachcho, the input here is x. X is also something that we call as independent variable. Because it is independent, yeah, right? It independently gets inside the factory, inside this juicer. So you're putting in some input like say oranges or lemon or mango in this season, right? In this juicer, and you are getting some output. What is the output? Output is y. We also call it dependent variable, right? And this juicer in this case is this function f, right? So if you keep on changing the different types of juicers, you'll keep getting different types of outputs, right? So the functions can be of very different types following very different rule sets. This juicer follows a certain rule set to either create a juice or a smoothie or something else, right? Similarly, this function f can be of many types, but today we are going to learn a specific function. And what is that function that we are going to learn today? Modulus function, right? So today we are going to learn this function. Function of x, y is a function of x, bachcho, and that function of x for today's class is modulus x, or absolute value function of x, or in short, lovingly we call it mod x, mod x in short in our day-to-day language, right? So y, which is a function of x, and that function of x is modulus of x. All right, is that clear? Chalo. But why do we call it a Baba function? Now this is my favorite part. This is how I imagined it when I was a young kid like you. So when I first read it, this is what came to my mind. Oh, this function is a Baba which removes all the negativity in this world. So what do I mean by that? For example, this Baba happily accepts. So the Baba lives in an ashram, for example, and the gates of the ashram are open to all types of people. Some are negative people. Say look at this number -2. Say look at this number -3. All, imagine -2, -3 represent people with negativity in them, right? They come to Baba, and then there are also people who are very positive, already positive. So imagine there are people like 5, like 6, all these are positive. They're already positive. So Baba says, positive people, you have no problem in this life. Go ahead. From my ashram, when you go out, you will remain positive as you were. So the output in this case is either 5 or 6. If you input 5, you get output 5. If you input 6, you get output 6. But if you input -3, so -3 comes inside, but it goes outside like a positive number 3. So what does Baba did? What did Baba do? It converted the -3 to positive 3. What did Baba do to -2? So -2 came inside, but it went outside the ashram, becoming positive. Right? It is very simple. So what this Baba does? It ensures that whatever be the input, what are all these? These are your inputs. Inputs can be positive, negative, 0, whatever. But the important thing is output of this function, modulus x, Baba function, is always, this output, remember, is always a positive number. It's always a positive number, right? So if you put anything negative, it becomes positive. If you put positive in the mixie, in the function, in this ashram of Baba, positive. Put negative number, positive. Put positive number, positive. Put 0 in it, 0. Because 0 is neither positive nor negative, 0 comes out as it is. Alright, so this is what Baba function does. So let's learn it in the form of mathematics now. So see, if you input -2, as I've written here, see, if I input -2, this -2 comes inside, Baba made it positive. But important thing to remember, Baba ने इसको positive बनाया कैसे? How did Baba make it positive? There is a very interesting way which Baba uses. Baba gives a negative number another negative. There is a negative, Baba is a special negative. So when this negative meets already negative, it makes a positive, right? So this becomes actually what? +2 because of that. Did you get it? Understand? So what is the way of Baba to make it positive? By giving it a negative number. That's it, as simple as that. Now can we understand it in terms of x? Right? So can we understand in terms of x? Let's try to do that. So imagine a negative number x. So here till here what did we do? We use the numerical numbers -2, -3, 2, 5. Now let's generalize it for any input x. So bachcho, if there is an input x inside the function, so what am I doing? See carefully, in terms of I am giving an input x. So left hand side I am giving an input x. Now x can either be negative or x can be positive. If x is negative, what will Baba do? Baba will make it positive by giving it a negative sign. So when you give it a negative sign, do you see this entire thing has become what? This -x. Can you tell me what is this -x? Is it a positive number or a negative number? This -x. Don't get confused by the minus sign, right? Anything with a minus is not always negative. If the thing with which there is a minus sign, if x itself is negative, then negative of x will become positive. So remember bachcho, this actually is a positive number. This is a positive number, right? Because this was a negative number. Because this was a negative number. Correct? So x was negative. Baba, it came to Baba's ashram. Baba, using his technique, gave him a negative sign. So negative sign, x with a negative sign, x was negative already. Imagine x was like -2. Imagine x is like -2. So -2 with a minus sign became +2. This is positive. If x was already positive, so can I write this as positive? If x was already positive, then what comes out is the same number without any change because it already was positive. Right? Now with this understanding, I hope you got it. Now with this understanding, can I generalize it and create a function out of it? So look at this very carefully. Now this is how I define the function. Look very carefully. So y, so what is my function of x? Y, the function of x is modulus of x or mod x or absolute function x or my Baba function. So y is mod x is equal to when x which is input, is already positive, when x is already positive, then the output is the number itself, no change, is x itself, right? X is positive, look at this green one, when x is positive, imagine 2. So when you input 2, the output is also 2. The output is also 2. Agree? Clear? So when the input is 2, output is 2. Now when the input is a negative number, so when you input a negative number, minus 2, the output is what? Output is minus of minus 2. Minus of minus 2, which makes it positive number 2. So if the input is a negative number, bachcho, if you are inputting or if you are giving it a negative number to Baba's ashram, so Baba will do what? It will not send the same person outside. It will send a changed person outside. And what is the changed person? Minus x. Remember, is minus x negative? Tell me, is minus x negative? No. X is negative. So minus x, bachcho, is what? Positive. Remember, this is also positive and this is also positive. Output of modulus function is always a positive number. So don't get confused here. Alright, now write down, this is the definition. So y equal to mod x is x when x is positive. Y equal to mod x is minus x when x is negative. Right? Another way, another important thing, what if I input 0 in this? What if I input 0 in this? If I input 0 in this, then 0 is also the output. No change. So, can I include 0? When x is equal to 0, then x is also the output. When x is equal to 0, output is again x, which is 0, right? So, I am including 0 here. So, now this is the complete definition of the modulus function. This is the complete definition of the modulus function. Clear here? Is this clear to all of you? Makes sense? Now, with this understanding, let us move ahead. Again, coming back to the same definition, y, which is a function of x, is mod x, which is defined like this. So, if x is positive, if the input is positive, remember, if the input is positive, this is the output. This is the output. Remember, output is always positive. In other words, this also implies that modulus of x, irrespective of x, x इसके अंदर जो भी जा रहा है, whatever the x is, this is always positive. This is always positive. Clear? And since y is equal to mod x, this also means that y is always positive, right? So modulus is always positive. So can you tell me the values here? What is modulus of minus 2? Minus 2 ka modulus, what is that? Minus 2 ka modulus is, Baba makes it positive. Baba makes it positive. Yes? Minus 2 was the input. What was the input, bachcho? What was the input? X. X was minus 2. So what is the output? If you get confused, what is the output, bachcho? You can also imagine the output as, minus x minus x. If x is minus 2, output, the modulus opens with a negative sign if x is negative. But this will become what? Minus of minus 2. Hence it becomes 2. Got it? Is this clear to all of you? Very step by step, I'm just taking time. Mod 3, no doubt it is 3. Input can be any number, any real number. It need not be integer. So we are discussing 2, minus 2, 3, 4. But it can be 3.14. It can be, root 2. It can be minus root 2, whatever. Any real number can be the input. Just that the output will be positive. So if the input is minus pi, what is the output, bachcho? If the input is minus pi, the output is simply pi. If the input is minus 10, output is, bachcho, what? 10. Remember, output is always positive. Clear? What if I tell you that modulus of x is equal to minus 2? What's the value of x? Can this be true? Can modulus of x be minus 2 ever? No, because modulus is always positive. Clear? This is all clear. Nothing special till now, but this is very important definition. Typically what children do the mistake as, they think of minus x as a negative number. Nah, minus x is positive because x itself was negative. X was negative, give it a minus sign, make it positive. Clear? Chalo. Now let's come to the another concept which will help us solve the problems. Now we are going to learn something which will help us solve the first variety of problems of modulus, based on modulus. Remember, today we are going to do problems with equality. Today I am not going to do the inequality. Today we are not going to do the inequalities. That is my next class on the modulus inequalities, right? That is very, very, very important as well. But today we are doing the basics. First, let's master the problems based on the equalities. For that, this concept is important. What is this concept? Note it down in your notebooks. It says mod x is equal to a. Hey, wait. If mod x is equal to a, can a be negative? So you need to define. A is positive because modulus of x is equal to a number. Since modulus is always positive, what it is equal to has to be positive. Mod x cannot be equal to minus 2. Mod x equal to 2? Yeah, correct. So mod x equal to a. It implies x is either a or x is equal to minus a. In other words, x is equal to plus minus a. How did that happen? Let us understand. Let us understand with an example. Say mod x is equal to 2. Say mod x is equal to 2. Like mod x is equal to a, mod x is equal to 2. Now my question is, what is this ashram happy to take as input? To give 2 as the output, right? So my Baba function, is my Baba function happy taking 2 as the input? Can x be is equal to 2? Yes. If x is equal to 2, my output is 2. No problem with that. My output is 2. No problem in that, right? But what if my input is a negative number? What if my input is a negative number? What if x is equal to minus 2? I'm okay with it. Baba's ashram does not stop any negative number from coming in. So if x is equal to minus 2, the output again is 2. To get the output as 2, my input can either be minus 2 or my input can be 2, and that's what the question is. For output to be equal to 2, for modulus of x is equal to 2, what can be the input? Input could either be 2 or input could have been minus 2. When you put x is equal to 2 or minus 2, both will give the output through the modulus function as 2. Hence, in other words, this can also be written as, in short, as x is equal to either 1, either plus or minus 2. In short, we write it like this. Got it? Clear? So, bachcho, remember, so what is this? So, to generalize, whenever you see mod x is equal to a, you immediately know that, oh, x can be either plus or minus a. Mod x is equal to 5. X can be either plus 5 or minus 5. Mod x is equal to 10. X could be either plus 10 or minus 10. Mod x is equal to root 2. X could either be root 2 or x could be minus root 2, right? So what it leads to is my first variety of problems. Now what is that first variety of problems? Say mod x is equal to 5. Alright, if mod x is equal to 5, then what do we do? That's what we learned, right? If mod x is equal to 2, it implies that my input or the value of x, what is x bachcho? X is always the input. My x could either be 5 or it could be minus 5. In other words, you could write this as x is equal to 5 or x could be equal to minus 5. Right? Plus minus 5. Now let's come to this. Ab in the place of x, I've expanded it. I'm just making it more complicated. Now this is the first variety of problems slowly beginning to unfold in front of us. Now in the place of x, what we have written, x minus 1. Now nothing, very simple. Whatever was inside, its value was either equal to 5 or equal to minus 5, right? Now what you need to do very simply is this. Now tell me what is inside. What is inside? Inside is x minus 1. Whatever you did with x here, x was equal to plus minus 5. Now whatever that is inside the modulus, now that thing will either be equal to 2 or that thing will be equal to minus 2. Got it? Okay? In simple words, this implies x minus 1 is equal to plus minus 2. Clear? Right? So again, quick revision. Mod x equal to 5, we learnt. It means the input is either plus 5 or minus 5. Now bachcho, what is the input for the modulus? Who's coming inside? Who's coming inside the ashram? Modulus is the ashram of Baba. Who is coming inside? X minus 1 is coming inside. X minus 1 is coming inside. Right? Who can come inside? A positive or a negative number. A positive 2 or minus 2. A positive 2 or minus 2 can come inside. So who is coming inside? X minus 1. That thing can either be 2 or that thing can be equal to minus 2. Now that leads to a solution. So that leads to a solution. How do we solve? Now let's individually solve these two with a or in between. Right? So when I solve this, take one on the other side, x is equal to 3, or when I solve this one, x minus 1 is equal to minus 2, take 1 on the other side, it will become x is equal to minus 2 plus 1, that is x is equal to minus 1. So what's your answer, bachcho? So what are the values of x which satisfy this? So its answer, it implies, becomes that x is equal to 3 or x is equal to minus 1. You can actually check it. Put x is equal to 3 in this. 3 minus 1, 2. Mod of 2, 2. Perfect. Put x is equal to minus 1 in this. Minus 1, minus 1, minus 2. Minus 2 ka input, modulus will make it plus 2. Perfect. Makes sense. So this is how we can solve these two kind of problems, right? Now this leads us to the graph. Now with this understanding of modulus function, can we plot the graph? Yes. How do we plot the graph? By putting down certain values of x and the corresponding values of y. Input, output, input, output, input, output pairs. Can we create that? Let's do it. So let's create input, output pairs. So x equal to, let's start with say minus 3, minus 2, minus 1, 0, 1, 2, 3. These are the inputs. These are the values of x. All of you know the output. What is the output? Mod x. Mod x is equal to y equal to mod x. So what is the input? Input was x. Input was x. It is written here. Let's find out the output. Modulus of minus 3, 3. Modulus of minus 2, 2. Modulus of minus 1, 1. Modulus of 0, of course 0. 1, 1, 2, 2 and 3, 3. So what are my pairs? What are your pairs to plot the graph? X, y coordinate minus 3, 3, minus 2, 2, minus 1, 1, 0, 0, 1, 1, 2, 2 and 3, 3. Agree? If you plot these numbers, the kind of graph that you are going to get is, it passes through origin 0, 0, then 1, 1. So when you have 1, this is also 1. So this is 1, 1, right? Then 2, 2, right? So when you have 2, then this is also, say for example 2. So 2, 2, so this is 1, 1. Oops. And this is 2, 2, like this. And similarly 3, 3. So 1, 2, 3, 1, 2, 3. So 3, 3 will be somewhere here, right? So if you join these points, तो क्या मिलेगा आपको? So when you join these points, see, so 1, 1, 2, 2, 3, 3, right? Clear? Now similarly, when you have minus 1, 1, so minus 1, 1, right? So minus 1, 1, what will be? Here, somewhere here. Then minus 2, 2, somewhere here. And then minus 3 will also give you output 3, somewhere here. So the graph will go like this. Do you observe? So see this. This is very important to understand. So the output is 3 for the input minus 3 and 3. The output is 3. So both minus 3 and 3 gives the output 3. Both 2 and minus 2, they both give the output 2. They both give the value of y 2. 1 and minus 1, when both enter the ashram of Baba, they both come out becoming positive 1. Right? Something like this. Agree? So this is the graph of y is equal to modulus of x. This is the graph of y equal to modulus of x. So y equal to modulus of x. Agree? Yes. So this is a beautiful V-shaped graph and it passes through origin, and remember this graph is always above x-axis. Do you observe this? Y. This is the y-axis, right? This is the y-axis. And this is the x-axis. So do you realize that the values of y that the graph corresponding to this green graph, all the values of y. So see, these are all the values of y which correspond to the graph, right? So this is the graph and this is the values of y that the graph gives. So this is the graph. These are the values of y which the graph gives, and y is always positive. This is always positive. So do you realize that here y is always greater than equal to 0? In the chapter of functions, you will also learn that this is the range of any function. The values that a function, the values of y that a function can take, or all the outputs that the function can take, is called the range of a function. Don't worry, we are going to learn that in the chapter of functions properly. What can be the values of x? Do you realize? In this machine, or this Baba's ashram is happy to take anybody, all the values of x. So that is called domain. So x can be any real number. So how do we read it? X belongs to all real numbers. X can be anything. The input can be anything, right? In the chapter of functions, we will read this as the domain. So what is the domain of the modulus function? All the possible values of x which belongs to the real numbers. It can be 1, 2, 3 or root 2 or root 3 or pi or 1 upon root 2 or 1 upon root 3 minus 1 by root 3 minus root 2 minus pi, whatever number that you are happy to take as the value of x. Okay? This is also clear to us. Some other aspects that we can think about from this graph. Shape, shape, right? Another thing which is important to note is this, bacho. See, if you look at the definition of this function, what was the definition of this function? So y equal to mod x, it behaves like y equal to x when x is greater than 0. So it behaves like y is equal to x when x is greater than 0, and it behaves like y equal to minus x when x is less than 0. What is x greater than 0? Positive side of x-axis. This is nothing but positive side of x-axis. And this is what? This is the negative side of x-axis. Now, so can I also say like this? When we are on the positive side of x-axis, the graph behaves like y equal to x. When we are on the negative side of x-axis, the graph behaves like y equal to minus x. Can we see this in the graph as well? Let's look at this in the graph. So see, if you look at this graph, if you have learnt a bit of straight lines in your class 9th and 10th, this is the graph of y equal to x. A straight line with the slope 1. But this line is restricted only to the positive side of x-axis. This line is not going down here because this is defined only for the positive side of x-axis, right? But this, which is y is equal to minus x. So y equal to mod x behaves like y equal to x for x greater than 0. It behaves like y equal to minus x for x less than 0. And y equal to minus x graph, this is this graph, slope minus 1. But this graph is only constructed, restricted to only this side of x-axis. Only this side of x-axis when x is less than 0. So this basically covers all aspects of the graph. Very, 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 very important graph. Okay? Alright, cool. So now, the next thing is, so just to summarize, this is the graph of y is equal to mod x. It actually can be understood as y equal to x or y equal to minus x, right? Under what conditions? This is the condition when your x is greater than 0. You can also put equal to 0 because this point is also included. By the way, greater than equal to 0 can be included here, or it could have been included here as well. But it is just a custom to include 0 with greater than sign. If you include equal to with this, no problem. Equal to 0, do it here or there, it doesn't matter because both these lines meet at origin. So 0 could be included with this, 0 could be included with this also. But it's just a custom that we follow to include equal to sign with the greater than 0 wala side. Alright, so this is the graph y equal to mod x. Now, very interesting thing to now observe. Can I now shift the graph? But what I'm going to learn in this next slide is, I know the graph of y equal to mod x. Can I plot graphs of can I plot the graphs of mod of x say minus 1 or mod of x say plus 1? Can I plot the graphs of these, which is y equal to this or y equal to this? Y equal to mod of x minus 1, y equal to mod of x plus 1. We will learn this as a concept what we call as transformation of graphs. Okay? And you can also understand this as, if function of x is mod x, can you say what is this written? This can also be written as, if f of x is mod x, what you've actually written is f of x minus 1. Just in the place of x, you have written x minus 1, which will give you mod of x minus 1. Now, in this, to reach here, what you have done? You have actually written f of x plus 1, right? Sorry, my bad, what have I done? This is f of x plus 1, which is equal to this, right? So in the place of x here, you have put an x plus 1. Basically, we are learning, if I know the graph of y equal to fx, can I plot the graph of f of x minus 1, and can I plot the graph of f of x plus 1, and that concept is called graph transformation. So that concept is called graph transformation. Now let's learn it. So you can note down in your notebooks, I am teaching you two very simple graph transformations. With my classes, you will learn many other types of graph transformations, right? So the first type of graph transformation is this. What do you know? You know the graph of y equal to fx. In this particular case, that graph happens to be y equal to mod x. Alright, now we are going to plot first the graph of y is equal to f of x minus 1, which in our case will become what? Y is equal to mod of x minus 1. Simple thing, remember always, if you know the graph of y equal to fx, if you plot the graph of f of x minus 1 or x minus 2 or x minus 3 or x minus 5, the graph will shift horizontally towards the right. It means what? Its graph now bachcho will be this shifted 1. See, this is 1. This entire V graph, move it by 1 towards the right. This is how the graph will look like. I'll explain why, but first note it down. So this is bachcho the graph of, this yellow graph is y is equal to mod of x minus 1. Y is equal to mod of x minus 1. In simple words, let's understand this y. Bachcho, what was this graph? The white one? White one was y equal to mod x. Simply, tell me when, for what value of x is y 0? For what value of x is y 0? When x is 0, when x is 0, the y is 0. Agree? But what should be the value of x here to make y 0? What should be the value of x here to make y 0? 1. Yes, correct. So in this particular case, when x is 1, then y is 0. So do you realize whatever was happening at origin here is now happening at 1, 0, and similarly for all other points. So this graph actually has shifted towards the right hand side. It has shifted towards the right hand side. Now with the same logic, can you also help me plot the graph of, say, y is equal to mod of x minus 1? Or in this particular case, how do you write it? The transformation is y is equal to, sorry, this is plus 1. So y is equal to f of x plus 1. With the same logic, what will happen? whatever was happening at 0. So what makes y 0 here? What value of x will make y 0 here? X is equal to -1, correct. So this entire graph now, bachcho, this white graph will shift towards the left hand side in this particular case, and it will look like this, and it will look like, bachcho, it will look like this. So shifting it to, arey baba, -1 comma 0, shifting it to -1 comma 0 here, okay, and it will look like this. So what is this green graph, bachcho? This green graph is, so this particular graph is y is equal to mod of x plus 1. Y is equal to mod of x plus 1. It is shifted towards, this is shifted towards left hand side, right, and the yellow graph is shifted towards right hand side. Got it? Okay, so keep this in mind. In general, so y is equal to, if I just summarize it, so x minus 2, bachcho, if you do x minus 2, mod of x minus 2, where will it shift? To right hand side. If you do x plus 2, 2 left hand side, x plus 3, 3 left hand side, x minus 3, 3 right hand side, minus right hand side, x plus left hand side. Got it? Clear? And this is true for all graphs. This is not just modulus graph. This actually is true for all types of graphs. So if I generalize, so see, I'll tell you some very beautiful graphs. So what graphs do you know? So you know the graph of y equal to x square, right? This is y is equal to x square. So what is the function I'm talking about here? F of x is equal to x square, right? So if you now write, if I were to plot the graph of bachcho, f of x minus 1, x minus 1 ka whole square. So how will the graph look like? Exactly same way, x minus 1, 1 towards the right, x minus 1, 1 towards the right. So this is the graph of y is equal to x minus 1 ka whole square, right? This is y equal to, okay? Clear? Now, similarly, what if I plot the graph of y is equal to f of x plus 1 or x plus 1 ka whole square? Y equal to x plus 1 ka whole square. How will it be? It will now shift to minus 1, right? And this, so this is the graph of y is equal to x plus 1 ka whole square. Got it? That's it, as simple as that. Cool? X plus 1, shift towards the left, shift towards the left hand side, and x minus 1, shift towards the right hand side, shift towards the right hand side. Got it? Clear? And just for your summary, again quickly revising, y is equal to mod x, right, the yellow one, mod x minus 1, right, and the green one, mod x, this one is mod x plus 1. Okay? All these, this is 0, this is minus 1, this is 0, this is 1. Got it? So this basically summarizes the entire graph transformation, but only the horizontal graph transformation. Alright, so bachcho, what do we call it? We call it horizontal transformation. Cool. With time we will learn the vertical transformation, and with time we will learn many other types of transformations as well, but this is the most basic one. Cool. Now let's come back to the problem which we were solving. What was the problem, bachcho? So now I'll use the graph understanding to solve this problem. Bachcho, remember we solved this problem? The modulus of x minus 1, what did we learn? Quick revision. We learned if modulus of x is equal to 5. Stop, take a deep breath. Just quick revision. Mod x equal to 5. Bachcho, what did we learn? That x could be plus minus 5, or input could be plus minus 5. What is the input for the mod or the ashram? X. Mod of x minus 1 is equal to 2. Input. What is the input to the mod? What is inside the mod? X minus 1. So this input could be either plus 2 or minus 2. So this input could be either plus 2 or this input could be minus 2. And then we solved. Can we visualize it using the graph? Now let's try to visualize it using the graph. So let us plot the graph of, so what was the question? Mod of x minus 1 is equal to 2, right? So, is this the question? What are those values of x when y, which is mod of x minus 1, is equal to 2? So let us first plot the graph of y is equal to mod x minus 1. This is the graph of mod of x minus 1. Agree? This is the graph. Yes? Now, when the y is 2, so this graph is shifted towards 1. The graph is shifted towards 1. This graph is shifted, mod x minus 1 is shifted towards right, 2, 1, right? Now, when is y equal to 2? So, modulus of x minus 1 is equal to 2 can also be understood as that this y in the graph of y equal to mod x minus 1, the y is equal to 2, right? So when the y is equal to 2, what are the values of x? Do you see? When x is 3, then the corresponding value of y actually comes out to be 2. And on the other side, when x is minus 1, then the value of y comes out to be 2 from the graph. But let's try to understand it deeply through the graph. Okay? Let's go a step deeper. Now, listen to me very carefully. So my function is y is equal to mod of x minus 1. Let me redefine this function. Very important, bachcho. Please understand this very, very properly. Okay? Take your copy and just write it out very, very properly. Okay? Y equal to mod x minus 1. Remember, the input or the x minus 1, how will I open the modulus? I want to write y after opening the modulus. How do I write it? When the input is positive, what is the input? Input is x minus 1, which is inside the modulus. When what is inside the modulus is positive, then ashram of the Baba says no change. So the value of y becomes, the modulus removes without giving it a minus sign. So what the output is? Output is x minus 1 itself. When the input which is getting inside the modulus is positive. Can I also write this as x greater than or equal to 1? So when x is greater than or equal to 1, this function y actually behaves like x minus 1. So when x is greater than 1, see carefully, when x is greater than 1, this side, when x is greater than 1, the function behaves like y is equal to x minus 1. This is actually the graph of, you learned in the coordinate geometry, y equal to x minus 1 is this line, right? In other words, when x is 0, sorry, when y is 0, x is 1, when x is 1, y is 0, slope is 1. Okay, now other thing, when the input of the modulus function is negative, when the input is negative, so what is getting inside the modulus? X minus 1. When x minus 1 is negative, whatever that is inside the mod, whatever you put inside the mod, if that is negative, then the modulus opens by giving it a negative sign, right? So whatever comes inside the Baba's ashram, if that is negative, Baba gives it a negative sign to make it positive. Agree? So this is x less than 1. So when x is less than 1, the y or the graph behaves like minus x minus 1. You can also write this as 1 minus x. So do you realize this? Look at this. When x is less than 1, when x is less than 1, when x is less than 1, the graph behaves like y equal to 1 minus x. So this is the proper definition of function. So what is the definition of function? So whenever you see y equal to mod of x minus 1, in the next step, you can remove the modulus and redefine the function as, the function redefines as no change. The modulus opens, no change, if what is inside is positive, x minus 1 is positive, that is x greater than 1, we usually put the equal to sign here. Now the modulus opens with a negative sign, the modulus opens with a negative sign when what is inside the modulus is negative. What is inside the modulus is negative. Got it? Clear? Okay? This is clear? So this is how we redefine the function. Very, very, very important. So this step is very important. Usually this is the first step in solving most of the problems. This is the first step in solving most of the modulus problems. Alright? Now the question was, where did we start from? Modulus of x minus 1 is equal to 2. Right? So for this side of the graph, when x minus 1 is equal to 2, so when y is 2, this side, do you realize x comes out to be 3? So x is 3, when x is 3, then the y is coming out to be 2. Same, the answer which came when we solved previously. And in this case, here, when you put y minus x is equal to 2, your x comes out to be minus 1. When x is minus 1, then also the y value is 2. Right? Clear? Alright. So this is the graphical visualization of the simple problem that we solved here. Mod x minus 1 is equal to 2. Simplest way to solve it, bachcho, is open this up, remove the modulus. Inside thing is either 2, inside thing is either minus 2, or inside thing is equal to 2, solve them. A proper deeper investigation tells us that actually what is happening. This function actually redefines itself as this function. Two parts, x greater than 1, it behaves like this, x less than 1, it behaves like this. And we equated both of these is equal to 2 because that is the value of y, and we got the corresponding values of x. Both are the same thing. Both are the same thing, but this is what we usually do. Whenever we see modulus of something is equal to 2, we remove the modulus and say whatever was inside is equal to plus minus 2. End of the story. Got it? Okay, now let's move ahead, but this is very, very, very important concept. We'll use this in problem solving a step further in a few problems later. Okay, let's solve a few more problems. Should we do it? Yes? Now, modulus of 2x minus 1 is equal to 2. What to do? Modulus of 2x minus 1 is equal to 2. Simple. Will we plot the graph again and again? Will we redefine the function again and again for such simple problems? No. Where we can operate with a needle, we don't run behind it with a sword. जहाँ सुई से काम चल जाए हम तलवार लेके नहीं भागते, ठीक है? So in this particular case, all that we need to do is simple. Whatever that is written inside the modulus, whatever that is the input, that thing will either be equal to 2 or that thing will be equal to minus 2. Simple. You got the graphical understanding previously, I am not going there again. I will come to that again in a more complex problem. But for such simple problems, where a modulus of something is equal to a constant, simply whatever that inside the modulus, make it is equal to plus the constant is equal to minus times the constant. Okay? And then solve both. So this becomes 2x is equal to 3 or 2x is equal to minus 2 plus 1 minus 1. So this implies x is equal to 3 by 2 or x is equal to minus half. Right? So these are the two possible values of x which will make this modulus of 2x minus 1 is equal to 2. Simple, clear, nothing, no confusion here. Alright? Okay? Now let's move ahead. What is the answer of this? Quickly, can you tell me in the chat? What is the answer of this? Modulus of 2x minus 1 is equal to minus 3. What should I do? Is it even possible? A modulus is always greater than or equal to 0, or in other words, it is always positive. Right? The modulus is always positive. So can modulus, this implies that modulus of 2x minus 1 is equal to minus 3. That's absurd. Not possible. It's not possible. So there is no value of x which can make it happen. This is beyond its definition. It's not possible. Okay? Clear? So bachcho, what will be the answer? The answer is none of these. Okay? Clear? आगे बढ़ जाए. Let's move ahead. Now this is another variety of problems where you will see the need of modulus. You will feel the need to use the modulus function ka knowledge to solve the problems. Alright. So you will see such type of things getting created while solving the problems of other chapters like quadratic equation, like sequence progression, like lots of chapters of calculus. Many of you who are droppers, you definitely must have encountered this again and again, right? So what do we do here? One important concept before we start this problem, and that concept is, bachcho, nothing. Put mod x is equal to t. Put mod x is equal to t, right? But what if the problem was like this? Bachcho, actually both these problems are same. Remember this. Both these problems are same. Here x square, you have here mod of x square. Remember, both are same. So you can actually make a note that x square can also be written as mod x ka square. And pretty simple to understand, right? So for example, here if you take x is equal to minus 2, or here if you take x is equal to 2, or here if you take x is equal to minus 2, or you take x is equal to 2, do you see the output will come out to be the same? Minus 2 square 4, 2 square 4 minus 2 का mod 2, 2 square 4, 2 का mod 2, 2 square 4. So all of these will give you 4, right? Both are same. X square can be written as mod x square. Basically, in both these cases, you remove the negativity either by squaring or by the modulus. The net output remains the same for the same input. So in both these cases, either this question or this question, if this is the question, you can write it like this. Then you can put mod x is equal to t, and then your problem starts looking like t square minus 3t plus 2 equal to 0, which is t, you can factorize it all of you, t minus 2, t minus 1 is equal to 0, yes? Agree? So this implies either t is equal to 2 or t is equal to 1, which implies, now this is important, right? How many solutions will you get? Can you observe? So what was t? T was mod x. So it is mod x is equal to 2, or, remember there is a or in between. There is a or in between. Either this, or mod x is equal to 1. When you solve, mod x is equal to 2, all of you know. Just now what we did, mod x is equal to 2. The input can be, for the output to be 2, the input to the modulus can be plus or minus 2, right? So x is equal to plus minus 2, and here x is equal to plus minus 1. Each में there is a or. In general, you can say the number of solutions are, so minus 1 or minus 2 or 2. All these are the solutions of this equation. Alright? Clear? So by the way, a lot of you who are asking in the chat, so this is the basics of modulus function designed towards the students of grade 11th who have just moved from 10 to 11th. This is the very basics. Students are asking about 12th. So 12th, I'll start the series from next week onwards, right? So I will do a series to summarize the ones who are in 12th. I will do a series to help you revise the entire 11th in like 15-20 days, and we'll do the regular topics of 12th. And for 11th graders, we are starting with the basics, and after that we'll get into the regular topics. But I'm going very slow with the basics, because if your basics are weak, bachcho, the foundation is weak, the entire tower tumbles down, right? And when you talk to the students of class 12th or the students who are taking drop, you'll realize how they really missed out on the basics in 11th, and that created the backlog, and that is why they struggle in their class 12th. So 11th graders, I know I'm going slow, but I want to go slow for you guys, because this looks simple, but trust me, these are the areas where you will make mistake, and that's what I'm saying with my experience of 15 years of seeing you children who are preparing for JEE, right? Okay? Cool. Chalo, let's move ahead. This is exactly what we did. Now, can you solve this problem? There is a slight trick here. Go and start solving this problem, all of you. Here, when you put equal to t, the values of t are very interesting. Cool. Yes, I'm reading your comments, but I am purposely not commenting because I'm anyways going very slow. So what to do, bachcho, here? What to do? Step 1, all of you, because I want something which you can put as t. So I want the same term repeating. So you see a mod x, so you feel like, why can't I make it mod x square? Because you know that mod x square is same as x square. है ना? And this is mod x, and this is minus x equal to 0. And in the next step, as all of you always do, you put mod x is equal to t to convert this into a quadratic expression which you can solve. So this is t square plus t minus 6 equal to 0. Now interestingly, when you factorize, all of you, so what are the factors? 6 is 3 into 2, but this is 1. So 3 minus 2 is what you want to create here. So you can write this as t square plus 3t minus 2t minus 6 equal to 0. This is basics, right? You have done it in your so many previous classes. So this is t plus 3 multiplied by, take t common from here and take minus 2 common from here, right? So t minus 2 equal to 0, as you have written in your chat. Okay, na? So the values of t are minus 3 and the value of t can also be 2. Now, which brings us to a very tricky situation. So what happens? So this is what I have done already for you. So what happens? So one root is t equal to minus 3. So for t equal to minus 3, since we took mod x is equal to t, so mod x is equal to minus 3. Arey, but mod can never be negative. So ye to ho gaya reject. Because you know that mod x, bhaiya, is always positive. Mod x is always positive. Remember? And mod x equal to 2. Yes, no problem. You can go ahead with it. This implies x is equal to plus or minus 2. That's the only solution you have. Right? So this equation has how many solutions? Not 4 but 2. Previous equation has had how many solutions? 4. In this case 2. Why 2? Because this got rejected. Very important, again a mistake which students do a lot. ठीक है ना? Clear? This is clear? Now let us do 2 more problems. This and after this one is actually very important one. So do this. Find x if, read it very carefully. Read it very carefully. It's a very, very simple problem if you read it properly. Don't get scared by 2 huge quadratic equations or quadratic expressions inside the mod. Read this as one modulus plus another modulus is equal to 0. I am giving you a hint. Do you realize that this is a modulus? Forget about what is written inside. Bhaiya, hai to modulus. Finally, it is a modulus. So, modulus is always positive. That is, either it is greater than or equal to 0. This entire thing is also modulus. By definition, modulus is always positive, either greater or equal to 0. Agree? Now, the summation of 2 positive things is coming out to be 0. Dude, how can 2 positive things be 0? It's like saying, imagine in your board examination, you have no negative marks, right? And somebody says that summation of your marks in 2 subjects is 0. What will you conclude? So in your board examination, you have no negative marking, and somebody says your marks in maths plus your marks in English ka summation is 0. You'll conclude that bhaiya maths may be 0, English may be 0. That's the only possibility, right? That's exactly the case. So this is your maths ke marks, this is your English marks, no negative marking. So the least marks you can get is 0. But if the summation of both the marks is 0, maths may be 0, English may be 0. So the only way to solve is, let's make both of these 0. So the only possibility is what? When this is 0, when and, remember I'm using the word and, both this should be 0 as well as this should also be 0. So when your marks in maths is 0 and your marks in English as well is 0, then only the summation of both the marks is 0, right? So you can solve them. Can you solve them now? Can you solve this? Solve. Okay, and then solve. Simple quadratic which you can solve, right? So what is this? Will give you, this is minus 5x plus 6, that is 3 and 2, right? So x minus 3 multiplied by x minus 2. So the solutions will be x is equal to 2 and x is equal to 3, correct? And here what is the value? X is equal to, so this is minus 8, 12. 12 is 6 into 2, 12, 6 plus 2, 8. Right, so it will factorize as x minus 6, x minus 2. So solutions are x2, x6. Can you tell me what is that value of x? When both are 0 together, remember I have used the word and here, and. Marks in math should be 0 and. The marks in English should be 0 as well. So that value of x which makes both of them 0 together, and that value of x, bachcho, is what? That value of x is 2, right? So x equal to 2 is the only number which makes this equal to 0 and this equal to 0 simultaneously. Hence that is the only solution possible, right? If you take, say, x6, then this becomes 0 but this doesn't become 0. Answer cannot be 0. If you take x is equal to 3, this becomes 0 but this doesn't become 0. So answer is not 0. Got it, Varun? Got it? Very important. Please mark this problem as important. Right? So this should be 0 and this should as well be 0 together. Both should be 0 together. Right? And whenever we do anything together, we use the word and. Alright? So then we solve this. So x is equal to 2, 3. Solve this. X is equal to 2, 6. This is the only value of x which makes both of them 0 together. So hence the answer is x is equal to 2. Got it? Now, let me come to the most important question of this entire lecture, and this is a very, very important type of question. So let's try to solve this. Right? If you solve this, then we have learnt the modulus function completely in totality in terms of problem solving, except one aspect which I'll do in the next class, that is inequality of the modulus function. Greater than, less than, equal to sign I'm not doing right now, but this is the most complex type of problem that you will see in the equality type of questions of modulus. Now how do we solve this? So there are two different modulus. Always remember one thing. First step is we want to open the modulus. So once we have opened the modulus, then we can deal with it. How do I deal with these modulus? I don't know how to add or subtract them. So I want to open the modulus. But to open the modulus, we'll have to redefine the function, or we'll have to check where what is inside the modulus is positive or negative, right? So create, right? So create different sections where what is inside modulus changes its sign. है ना? And then redefine the function. Redefine function by opening modulus. ठीक है ना? So you want to open the modulus, and this is the steps to do it. And then solve. And then solve. These are the steps. But how do I open the modulus? By checking that what is inside the modulus, where it changes its sign. So now look at this. Can you tell me where is this modulus x minus 1 changing its sign? Remember its graph? After 1, before 1. Where is this 0? Where is this 0? We call it a critical point. Where is this 0? X minus 1. It is 0 at x is equal to 1. Agree? X minus 1 becomes 0 at x equal to 1. Remember our last class of wavy curve, we did the same thing. X is equal to 1. Now what I am going to see, that x minus 1, what is written inside? It is positive towards the right hand side of 1. Agree? So x minus 1 is positive for x greater than 1. When x is greater than 1, x minus 1 is positive. Agree? So towards the right hand side of 1, x minus 1 is positive everywhere. Do you agree with me? Towards the right hand side of 1, x minus 1 is positive everywhere. But towards the left hand side of 1, x minus 1 is negative when x is less than 1. When x is less than 1, x minus 1 is negative. Agree with me? Yes? Now similarly, let's look at the sign of x minus 2. Same. Should I repeat the same calculation? No, you can do it. Towards the right hand side of 2, where is this? What is its critical point? X minus 2 का critical point क्या है? 2. So where is this changing its sign? 2. 2. Exactly like this. It was positive to the right of 1. It is positive to the right of 2. It is positive to the right of 2. What is? X minus 2 is positive towards the right hand side of 2, and it is negative towards the left hand side of 2. It is negative towards the left hand side of 2. Agree? Do you see you have created the sectors? You have created different sections. So what are the 3 different sections? Less than 1, between 1 and 2, after 2. Do you see how x minus 1 and x minus 2 is changing its sign? Now what I do, I am going to redefine the function very carefully. See very carefully. Let me take 3 different sections. Section 1, more than 2. Section 1, when x is more than 2. When x is more than 2. When x is more than 2, right? So this is positive, this is positive. When x is greater than or equal to 2, this and this, both are positive, both are positive. When both are positive, what is inside the modulus? If that is positive, modulus opens with a positive sign, no change. Whatever is inside the modulus, if that is positive, you can remove the modulus, no change, absolutely nothing. Baba says, the way you came, please go like this because you are already positive. Remember? So I will open this and this modulus with no change. So how do I write it? I write this as x minus 1, this modulus opened, minus x minus 2. Agree? Right? We can simplify it in your notebooks. Please simplify that. Now let's take the second case. The second case is when x lies between, this is the second case. What is the second case? This is the second case. when x lies between 1 set 2, when x lies between 1 set 2, right? So which one is negative? X minus 2 is negative. When something is negative, its modulus opens with a negative sign. All right, let's do that. Okay, so x minus 2 its modulus opens with a negative sign. Its modulus opens with a negative sign, right? Don't confuse with this negative, that negative will already there. We have just dealt with the modulus, right? So this bracket is this modulus. This modulus, I have opened this modulus as minus of x minus 2. This sign was already outside. Now let's come to x minus 1. Now x minus 1 was positive. X minus 1 was positive between 1 से 2. So it opens with a positive sign, no problem. Agree? ठीक है ना? Clear? So don't get confused. This is the modulus वाला part. This is the modulus वाला part. This is the modulus वाला part. Alright, this part. Okay, now let's come to the third. Now let's come to the third one, which is what is the third zone? Third zone is this one. What is this zone? X less than 1. So x less than 1. Sorry, I didn't write the second zone. It's custom to put the equal to sign with the greater than, because even if you put it here, no problem. Even if you put it there, no problem. It's okay. Okay? But it's customary to put it with the greater than. Now x less than 1, both are negative. Both are negative. So both modulus will open with a negative sign. So let's open this with a negative sign. Let's open this also with a negative sign. That's it. You have redefined the entire function. You have redefined the entire function. Now can you tell me what is this coming out to be? You can actually write it down, what it comes out to be. This will be x minus x cancel ho jayega. It will get cancelled out. X and x cancels out. Minus minus plus 2 minus 1. I think it should be 1. You can check it. I think this is 1. Okay. Now let's look at this one. Minus x minus minus plus x cancels out. Okay. So minus x minus minus plus x cancels out. Then here it is plus 1 and here it is minus minus plus 2 minus 2. Minus 2 plus 1 minus 1. I'm just doing it verbally. You can do it on your own. Right. So the function behaves like f of x is equal to 1 when x is greater than 2. F of x is equal to minus 1 when x is less than 1. And what is this one? This will be x minus minus plus. So it will be 2x. 2x and then minus minus plus minus. So this will be minus 2 minus 1 minus 3. So function behaves like f of x behaves like 2x minus 3 when x lies between 1 and 2. Right? So quick revision bachcho. For such problems where there are multiple modulus, step 1, make a number line. Put down the critical points of these two where it becomes 0, So x equal to 1, x is equal to 2. Put them on the number line. Alright. And then put down their respective signs. It is positive to the right of 2, positive, to the left of 2, negative. This one is positive to the right of 1, positive, to the left of 1, negative. Now you have the signs of both of these in all the intervals, Now redefine the function by opening up the modulus in all these zones. In this zone, x less than 1, this modulus opens with a negative sign, its modulus opens with a negative sign. Between 1 and 2, its modulus opens with a positive sign, its modulus opens with a negative sign. After 2, both these modulus opens with a positive sign, and now you have the function. Bachcho, this is the function. I'll just summarize it for you. So this comes out to be the function. Check 1 minus 1 2x minus 3. This is actually the function. So this entire thing actually is this. But what was the question? Question was this thing is equal to 10. This thing is equal to 10. It means that let's solve this into 3 parts. X greater than or equal to 2. This thing is equal to 10. Let's solve, right? So this thing for x less than 1 is actually 1. So the question converts into actually the left hand side. The left hand side actually is 1, right? And this left hand side in this particular case is 2x minus 3. And this left hand side in this case is actually minus 1. Now what is the question? The question is equal to 10. Doesn't make any sense, right? Is equal to 10, the right hand side, doesn't make any sense, right? Equal to 10, okay? This we can solve. Let's solve it. So 2x is equal to 13, x is equal to 13 by 2 or equal to 6.5. But there is a conflict. This we solved for x lying between 1 say 2. Answer is x equal to 6.5. No, it doesn't make any sense. Reject. Did you understand this? You realize that since this case was created for x lying between 1 say 2, but x is coming out to be 6.5, implies no solution here as well. No solution here as well. So no solution here, no solution here, no solution here. It means for this problem, there is no solution. Remember, this is very, very, very important variety of problem. If you're in class 12th, same problem comes for differentiability and continuity. Do you remember? All the children who are in class 12th or droppers, right? You will given this function and it will ask its continuity and differentiability. This graph, this graph, this graph between these intervals. Check the sharp corner. Remember? For 11th graders, what I am speaking should give you a hint that such things will be used in so many chapters. What I just talked about is the chapter of continuity and differentiability in class 12th, right? Area under this graph, integration. So many topics, same concept will be revised again and again. All right, cool. So please revise it. And now let me give you home assignment problems, bachcho. So today what did we learn? A quick recap. Today we learnt about modulus function. You visualize this as Baba function. The end goal is to keep the output positive. Input can be positive, negative. Output is always positive. Baba makes a negative thing positive by giving it a minus sign, right? Then we learn different types of problems that we can solve, and this is for you to solve. So home assignment problems, simple ones. You can take a screenshot or pause it here once this video gets created. Solve them. These are the 5 problems that I am giving you. I'll share the solutions here. I want you to put down your answers with the question number. So 1 answer, 2 answer, 3 answer, 4 answer, 5 answer. Please, after you have watched this video, quickly put it down in the comments, right? And I'll share the solutions and furthermore assignments on this Telegram group, which is where I, Anand sir, Pahul sir, we all are there. So t.me-v_wap. Okay, cool. Chalo, see you around in my next class with more basic concepts. Very soon I'm going to start the series for class 12th. I will also do a short series where I help all the 12th graders revise their class 11th, clear their backlog in 15-20 days, right? Starting, all these things will be starting from next week onwards. In the meanwhile, bachcho, keep smiling. Y equal to x square. You look beautiful when you smile. And that's how you should be. Tension nahi lene ka hai. You have a lot of time at your hand. Whatever time is there, it's enough if you start from today. Alright? But you need to do it with confidence and with smile on your face. See you in my next class. Bye-bye.